How?
All right, here we are back for the real class. How's everybody?
I'm okay.
Okay, good. So did it work, Chantel?
No.
What happened?
It's giving me an error. It's giving me an error. Once it showed me that it downloaded, right? But it says an error opening help in Windows based on program. Future
Okay,
not included.
Are you in a Windows computer?
Yeah.
All right. So all I can say is up at the top, they got that support here. See that? Because I don't see. Let's see. There was one other student that did it. I was going to get a report back from her before we decide what to do here.
I'm gonna try one more thing. I'm gonna try my Mac. See what they let me do it on my Mac.
Yeah, now Mac needs a different file, I think. I don't see, that's the thing is I don't understand about Macs.
Okay.
I think they can use the same file. Yeah, it's just downloading one. It doesn't say anything about whether it's Mac or. So let me ask, Matthew, you got everything running for this, for the Windows, for the 120 class, that respond us?
Did you say me?
Yeah. Did you get everything all right?
Yes, I did.
So which one what did you download?
You just go to the main page and you click the Windows one. You got to click Windows or Apple.
Okay, was it the one, the link that I gave you, this one?
No. Let me see where. Hold on one second.
Yeah, if you find a better link, I want to get it and put it in there because.
Give me 1 second.
Yeah. I don't know. I mean, I'm just a little bit concerned about this. Let's see.
That's it.
All right. Because I put that one in there, and I don't think that one's right because I don't see any way to actually download on that page. But if I can't get it today, I'll contacts. Let's see. See, like this one. Is a different school. Let's see if they got a. See, I'm not getting one of those, but I mean, I set that quiz up myself, so that's why I need a link because I don't.
But then you having the lunch. I'm so sleepy. I can't wait to go home.
All right, so if you find it, Matthew, just put a link to it for me in there. I just do that together in a minute. I didn't think about. And the truth is, we're not going to need to use that fully. It's just for the, to verify that it's you kind of thing.
All right, you click that in the chat, and it's on the right hand side, Windows or Apple.
Okay, this is the one. Okay, you got to watch this out because there's two different things here. This works for the Alex, and Chantel, you said you had that working, right? All right. But what I'm talking about is in the 120, this verification quiz. Did you do that, Matthew? Okay, so that's the one we do. What I'm going to do, I'm going to look around and make sure I can get the right one and make sure it's in there because everything I'm looking at says that it should be in there. Let me just look in here real quick. If there's something in here. Okay, so in that lockdown browser section you got. So this is the one you want right here. Let me so this is the one we want right here. So this one right here. So see where I'm at? in lockdown browser. So they are right that it's in there. It's just that for some reason it didn't put it in the quiz that I created. And then you want this one here. So I don't need a link to this. It's just in Canvas, go down to lockdown browser. So Brandy, did you get yours working? All right. I'm curious about what link you did, but I think I found a workaround because in Canvas, there's that in the lockdown browser section, they've got the information right there. So somehow you got it right. Did you do that 4.0 one?
No, I just went back and I selected the Mac because I have the Apple Mac.
Oh, okay.
It's letting me,
So
and then one, I actually tried, I was having difficulties before because I also have a school email, like not the email, but I actually work for a school district. So then it was telling me that I couldn't do anything because I had Castify. So
wow, yeah.
And it's been throwing me for a loop for a while, so I'm trying to figure it out. But I'm gonna check it once we get off of this one. While we had that small break, I did the.
All right, it's not that big of a deal if you do the one and if you're in the 020 class, that one will suffice as far as I'm concerned. But I know there's technically a few people in here that's not in the 020, so
Okay.
I'll
Thank you.
Because I'm clicking on this too, and this is just instructions. I don't see where the link is to the. Oh, it's right there. Well, that's a movie. I just got to find somebody that knows about the Canvas version. I've always used the Alex, and so all right. Well, just let me know how it goes tomorrow. Like I said, it is. I'm not going to read too worry about it because we got a couple more days for this. We're not going to use it for the first test, and like I said, I think we're going to use something else called Honor Lock anyway when we get to the midterm and final. All right. So anybody got any questions outside of the respondents? I'm sorry I wouldn't get that long. I just assumed that the download would be easy to find, and I'm wondering. Let me just look at one more thing. If every school has a different download, you got to have a specific one. Let's see. Said respondents was in here. Not it. This is just general information. And that's the same thing. All right. All right. I don't know who to contact now that I'm thinking about it. But like I said, this is for the Alex. That's for the 020. If you got that one working, then that's 75% of everything. All right. So what about anybody got any questions about material? We stopped right around here talking about the complement, and then in the 020, I just kind of revisited the union, the intersection, and the complement, because usually those are the three things They make up what's called set operations. And I'm going to do a set operation soon here. So those are the things that we need. All right. Now, I kind of handle things a little bit slightly different than the way that Alex does it because I don't really understand the way that Alex does. When they give you a Venn diagram, they'll give you something, well, they'll give you this, but they won't have these numbers in there, the Roman numerals. They won't have these Roman numerals. But a lot of other books do use these Roman numerals, and then all they really mean is this. That Roman numeral 1 is just what's inside of A only. Roman numeral 2 is what's inside the football, the complement. Roman numeral 3 is what's inside of B, but of course not in A. And then Roman numeral 4 is what's not in either one of them. All right. So when I handle these set operations things, I generally do it like this because I just don't see a strategy in the way that Alex does it. And if you understand it, all the better to you. Maybe you can explain it to me. But that's what we're dealing with here is how to do these. Well, I do it in a little bit simpler fashion. The way that Alex doing it is a visual kind of thing. But anyway, when you got a 2-set Venn diagram, this is the way it works. All right. So if you got a 3-set Venn diagram, it's like this. It's a little bit more complicated, but basically what it is 5 in the middle is the intersection of all 3 of them. 2 is the intersection of A and B only. 4 is A and C only. 6 is B and C only. And then this is A only, B only, C only. And then the one out here, the 8, is none of them. So that's kind of the way I look at them. So with set operations, I'm going to show you one in a second here. But to do that, I'm going to show you this thing, De Morgan's laws, it's called. And it's got 2 parts. Part 1 and part 2. Now, part 1 just simply says that little line out there, since it's outside the parentheses, means A union B complement. In other words, find out what A union B is, then take its complement. That's what that's equal to. On the right-hand side, it's the complement of A intersected with the complement of B. Now, I want to try to show you this using that little diagram. See how I can do this. All right. To do that, I'm going to take and grab these, and I'm going to put them up here. And this is what we're going to try to prove here. I'm just going to prove this one side here. All right. First of all, always work from the inside out. One of the reasons I gave you those order of operations problems in the 020 is because doing order of operations, whether it's with math or with the set theory, it's really the same process. You always work inside out. Find your most complicated part, start in the most inward place that you can, in other words, inside parentheses, and you do that first. So inside of the parentheses, we have A union B. So I need to find out what that is first, because unless I know what A union B is, I can't find its complement. So what I'm going to do then is this is A. I kind of cut it off a bit. Let's see if I can go a little bit further. So A union B are these two circles and anything inside of them. We don't need to repeat them. Inside of these, now these are not elements, it's just labels, but it's going to work the same principle. But Roman numerals 1, 2, and 3, in other words, that section of A that's A only, the 3, the section that's B only, and then the 2 Roman numeral, the section that belongs to both, are the only 3 things that make this up, the 3 areas. 4 outside is not part of the union of A and B, it's outside. All right. So A union B is just going to be this simple. Okay. Now, in a sense, the universal set is all 4 of these, 1, 2, 3, and 4. So what's not in A union B? Well, we can take those 3 out. The only thing that's left that's not in A union B is 4. So therefore, this right here, that right-hand part is A union B complement is, you don't need to have them in the brackets. I'm just kind of showing you what's in them. It's not really a set. So let me just type it out. So what that means is, as far as your working Alex is, they're going to have you shade things. So let me just kind of show you how you can do this. Once you've figured out what region needs to be shaded, you can use a shading tool wherever it's at. You can use this. And they got a nice little tool that just lets you select one of the 4 regions. You can select multiple ones, but the one in yours be just this. And I could do this in one of the Alex problems for you with the shade, and I may do that on review day. But I'm still going to come back to my little magic way of doing it with the Roman numerals. Okay. So that's what makes up A union B complement, is just region 4, the outside of the union. Now I'm going to do it like this now and find out now what is a complement. So I'm working on the right-hand side. I'm sorry, the left, yeah, the right-hand side. So that's just 1 and 2 that make up A. Okay. See, here's A right here. Right there. There's a 1 and the 2 inside of A that make up A. So A complement is everything that's not these 2. All right. Well, that's 3 and 4. Okay. So 1 and 2 makes up A. What's not in A or its complement is 3 and 4. Let's do the same thing with B. I'll tell you what, I could go ahead and erase this and replace it with B. So B is this one. That's making up 2 and 3. Well, that means that the complement of B is now 1 and 4. So the complement of B complement, I'm sorry, it's 1 and 4. So that's not in B, that's not in B. So now on that right-hand side, there's the intersection. So we're going to take the intersection between A complement and B complement, and what's in common is the 4. And you notice what? That's what we got shaded on the left-hand side. So that's how the set operations work. You have to work them one step at a time, inside out, basically. Most complicated part, and work outward. So like on that left-hand side, we had to figure out what A union B was before we could figure out its complement. On the right-hand side, well, we already know, we can see A right there. We can see B. When you have to do something with a more advanced operation like a union or a complement, you're going to have to put in an extra step. So then that holds, and then you got my word that this one holds as well. This can be very helpful in certain situations, especially in chapter 3, because we used the Morgan's laws over there for logic. And so if you recognize the pattern, it's very helpful. And I'll show you this pattern. A union B complement is equal to the intersection of the complements. So what that little sign right there does, it's sort of like we're distributing it to all 3. We're distributing it to A, we're distributing it to B, but it causes the union to flip upside down, because essentially that's what it is. It's the complement of it. So that's why we flip that up down. Notice on this side, on the left-hand side now, we have the intersection of A and B, and so the complement of that. So when we take the complement of that intersection, it becomes a union. And then the complement passes on to the other 2. This right here, if you understand this, or it's basically, if you can see that pattern from one side to the other, it would be very helpful, especially in chapter 3. But this is how set operations work. This is how set operations work. All right. So just take a gander at that. No. All right. Let's see what else we can do. So when you're dealing with set operations, this is the best way to handle it, in my opinion, is use those Roman numeral regions. And then when you find out which region or regions represent your set operation, then you can shade those in real easy with the Alex tool. But they've got their own explanations over there. So if you understand it, by all means, don't go for it. But I'm going to kind of handle it from this basis when I do help you with things. Let's see here. All right, let's do a little bit more with set operations. Now we're doing it with things inside, actually elements inside. So we've got the universal set is defined as, and it's in the more complicated form. So we got to understand how to interpret it. But it says it's a natural number. So that means it doesn't include anything in between. It starts at 1 and then goes all the way to less than 20, okay? So as you see right there, that's it right there. I wrote it out for us. You got to watch wording, because if it says less than or equal to 20, you would include the 20, of course. Just less than, then leave off that number. An odd natural number less than 16. Okay, so that's 1, 3, 5, 7, 9, 11, 13, and 15. And that's it right there. Now B is you may not know what a prime number is. It's not really that important, but these are rather small ones, and there's only a handful of them. But that's a prime number is just a number that's only divisible by itself and 1. So I'll just kind of show you here. So 1 is not a prime number because it's just not. It's only divisible by 1, and 1 in itself is the same. But anyway, 2 is a prime number because it's only divisible by 1. 2 is divisible by 1 and by itself. Same thing with 3. It's a prime number only divisible by 1 and itself. 4 is divisible by 2, 1, and itself, so it's not prime. Not prime. 5, only divisible by 1 and 5, so it's prime. I'm putting the dot over the ones that 6 is divisible by 2, 3, and 6, so no. But 7 is only divisible by 1 in itself. 8's got 2, 4, and 1. 9's divisible by 3. 11 is the next one. It goes rather quickly. 13 would be the last one. So these are the ones, and I've got them marked down a bit. But I just wanted to show you that I'm picking them out. Okay, now it was greater than 5, so it only includes these. Oh, and it's less than 20, so we got to include 17 and 19, I should have said. Again, I was looking at the wrong instructions. I had prime in my mind, but there we go. So it's greater than 5, so that's 7, 11, 13, 17, and 19. But anyway, it's real easy to tell what a prime number is, because if it's only got 1 in it itself, then it's prime. And there's fewer as you go out. All right, so that's what this is here. So the first thing we want to find is the number of elements in A prime, A complement. Well, A complement is just what's not in A. So the way I do it is sort of like this, especially if I can actually write on stuff. So you just have to write these down if you're doing them off the screen, usually. But not in A. So A is 1, 3, 5, 7, 9, 11, 13, and 15. Okay. So those blue ones up there in the U are my A. What I want is A complement. So 2, 4, 6, 8, 10, 12, 14, 16, 17, 18, and 19. Okay. So the number of elements there is simply 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you need to find out what's in that set. And then the reason why I'm doing the cardinal number is because you have to do both. You have to both find out what the set is and then count it. In some of your problems, it'll just say, find this set using set operations. All right, now we want to find the number of elements in A complement union with B. So then what we're going to do is we're going to take this set and this set, and we're going to squish them into one. Anything that repeats, we only put it in there once. So that would be 2, 4, 6, 7, 8, 10, 12. There's 11 goes in there. Then 12. These are basically just, most of these are even numbers in the A complement. So 12. And there's 13 goes in there. Back to these 14, 16, and then we're going to bring 17 up there, down from there. It's a prime number. And then 18 and 19 finishes out. So the number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the number of elements in that set, A complement union with B, is 14. All right, we all right on that? So basically 2.3 is about set operations. It does a little bit into De Morgan's laws, which is part of set operations. You don't really have a whole lot of usage for it yet, but it is important to realize that this holds true throughout. That if you take the complement of either a union or an intersection, then what you have on the right side is the equivalent. All right, let's see. I just feel like I'm missing something in here. Let me do something real quick. I'll be right back. Let me stop the share a minute. Oh no, I gotta go in as a. All right. Okay. So let me just point out over here. In the this is an example of one of your problems over in the Newton. Okay. So see this right here? They use this alternate symbol. That's the same thing as this. Okay. So they just happen to use that C there when it stands for complement, but it's in the same place as the apostrophe. Just remember that, okay? All right, let's go back over to where we were at. I guess it's in the 2.3. I just wanted to make a little note in here for that. Well, where did I put it at? Oh, there it is. There's a way to put a little thing in there. I wanted to. I'll put it in there in the class, but I wanted to show that that's the definition. You had both. I know I mentioned it somewhere, but I'm just now realizing that they're doing it in Alex. All right. All right, so let's talk about a survey problem. Now, a survey problem is just an application of the set theory stuff. So again, we're looking at this kind of thing like this, where it'll start with a two set Venn diagram. And let's say we got this question here. And I'm going to put this up here so that we can be able to see it, because I'm going to fill in this little Venn diagram with the answers. So what we're going to do is just read the problem. In a survey of 85 college students, 72 use Instagram, 31 use Facebook, and 21 use both. Okay. So usually the best place to start is at the end of the sentence. And we got right here that 21 do both. Let's say this is Instagram. And then this is F for Facebook. So I and F. All right. So there's both. So 21 use both. Now we're going to back up and we're going to go to 31 use Facebook. What do you think we're going to put in here? Can we just throw a 31 in there like this? Can I put that in there and satisfy that? What's the problem if I throw that in there? How many now are in the blue Facebook circle? Count the numbers. It's 21 plus 31. So I now have 52 in there. But see, there's the problem, because it says 31 use Facebook. So everything has to add up to 31 in that Facebook circle. So what am I going to do? I'm going to take the 31 that it should be, and I'm going to subtract the 21 we already know about. And so then what goes in here in the Facebook only category is 10, because 10 plus 21 is 31. So now we've gotten that to where it balances out. So we're going to have to do the same thing here for the Instagram. In the Instagram circle, there's supposed to be 72 total. But there's already 21. So I'm going to take 72 minus 21. So then that's going to be 51 there. Now, all three of the Roman numeral sections, the Roman numeral label sections, should have a number in there, an actual count. So how can I find out what goes here? Well, it's telling us that all of this, the whole survey, has to add up to 85. In the three here, there's 51 plus 21 plus 10. So there are 82 people that use Instagram, Facebook, or both. So what that means is 85 minus 82 gives us 3, and that means there are 3 people who are using TikTok or whatever. They're not Instagram or Facebook users. So now, did you have a question, Chantel? All right, so
No, just count them all.
all right, that's good.
Right.
I'm glad to see you going along. I just want to make sure you wouldn't want something. Okay, now we're going to be able to answer each one of these questions. How many use Facebook only? See that? Now we figured that out. Because if we had put that original number in there, that 31 right there, we would have just answered 31, right? And then we would have had more than actually use the service. So this is 10. That's the Facebook only. How many use Instagram only? Well, that's the one over here. The one in Roman numeral region 1, the one that's not touching inside of the blue circle. And you'll notice that with each one of these numbers, there's something that we actually had to calculate. by doing an addition or subtraction. So now here, how many use neither? Well, it's just basically saying how many are not in the union of Instagram and Facebook. Well, that's these folks out here. That's the 3. That's the neither. Okay? Questions? If you got anything, make sure you understand it. We're going to do another one. All right. So let's so I'm using the same one because if we got 2. Oh, this goes down here. Oh, wait a minute. It was this that I took out. Okay. So this one's got 2 of them here. All right. In a class of 25 students, 18 were math majors, 12 were computer science majors, and seven were dual majors in math and computer science. All right. So first order of business is fill this thing out. Then once we do that, we'll be able to answer the questions. All right. So 7 were dual majors in math and computer science. So let's make this math and this the CS side, computer science. All right, so we've got the first information. It says 7 were dual majors. That's the ones that are in both. So we're going to put a 7 there. All right, now what we're going to have to do is as we go out and fill out these things, we got to subtract. 12 were computer science majors. In other words, the whole of the blue has to be 12. So the 12 that should be in computer science minus the 7 that's already there. So that means we're going to put a 5 here. And that's a computer science only people. On this side, 25 students total. It says 18 were math majors. So 18 minus the 7 that are already in there. So there's going to be 11. All right. And then the last thing to fill out is region 4. So we've got in there total, we've got 11 plus 7 plus 5. So 23. It's 25 minus 23 means that there are two people that are majoring in philosophy, something else. Okay. So now, once we've got all 4 regions filled in, we can now answer questions. How many students were majoring in math only? So math only is the M section, and it's the Roman numeral 1, so it's 11. Okay. How many students were not majoring in computer science? You got to use a little bit of imagination here. And computer science is this region here. I've got the wrong thing. That's the disappearing ink. I need this like highlighter. So this is computer science. And it's saying not computer science. So the ones that are not computer science are these guys and these guys. They're not computer science. They're not computer science. These people are majoring in computer science and also something else. So we need the 2 plus the 11, 13. And then how many were not either one, not math or computer science? Well, that's just the 2. That's just the 2. So we don't know what those were majoring in, but they're not math or computer science. All right, so this is the way it works with the 3 sets. So let's see what I can do first. Technically, we don't have to finish until tomorrow. So I may do one of these set operations before we do an actual survey, because we didn't really look at the set operations with 3 yet. All right, which is in section 2.4, but still, when we first start covering it in 2.3, it's just with 2, and then you get 2.4, then they do 3. All right, so what they're asking is, are these equal? So I'm going to kind of do the same thing that I did with just the Roman numerals, because we don't really have any elements in here. We're just trying to find out if it talks about the same region. So I'm doing the same thing that I'm going to do. A union B. And A union B is just anything that's in the 2 circles. 1, 2, 3. So all of those, that's inside of A, so it's an A union B. This is inside of both, so it's A union B, 3. This one's inside of A union B. It's in C, but it's still in A. This is in B and C and A, but it's still in A union B. And then 6 is also in B. So all of those things are A union B. Now, C is just, of course, those 2. So A union B union C is going to be just putting all those together into one. So it's 1, 2, 3, 4, 5, 6, 7. That's A union B, C. It's everything except the one that's outside. Now, what this is designed to show you is no matter how you do it on this first one, it doesn't matter which ones you group first. So we essentially did it like this. So let's just do B union C first. B union C is just everything but 1. All right. And then A is, of course, 1. And then when we take the union of the two parts, all of them. Because whenever you put two things together, you just clump them all together. There's no missing ones here, but A does involve bring the 1 along with it. Okay. So no matter how you do it, as far as this, as far as the grouping is concerned, and I think this also works with the intersection, but with the second one, it's not just the intersection. It's got several things. Let's just see if we can handle this real quick. Again, this is falling under the concept of set operations. Sometimes you just be doing it when they have elements in there. As a matter of fact, Alex doesn't use the Roman numerals, but I don't know about the Newton yet. It may well be they may well use it. I can't remember. I know I looked at them, but I just can't remember. I guess Alex was unusual in that it didn't do them. All right. So B is 2, 3, 5, 6. See that? Inside of the B, there's 2, 3, 5, and 6. C complement is just what's not in C. So probably the best way to do it is just kind of show you that that's your C. So it's anything that's not in that circle. So that's going to be 1, 2, 3, and 8. 1, 2, 3, and 8. I'm sorry, 7. Yeah, 1, 2, 3, and 8. 4, 5, 6, and 7 are inside of C. So this is C complement. All right, that's C complement. So then B, I'll have to come back and put that symbol in. So there's your complement symbol. So now we're going to find out what's complement between, I'm sorry, not the complement, so the intersection symbol. Look, what's the intersection between these two? And it looks to be 2 is in there, 3 is in there. And I do believe that's it. Because 1 is not common to C. 1 is not complement to B. It's not in B. 2's in both, so that's the complement. 3's in both. Nothing else. So then the whole part, and we need a complement to do this. It's just what's not in A. So that's 3, 6, 7, 8. So A complement is anything not in A. So that's 3, 6, 7, and then that should be an 8 there. Always double check. But see, it's easy to make a little mistake. And once you write something down, if you write it down wrong, you'll believe it, especially when you're like, in testing mode. Always double check. All right, so now we're going to take these two here, these two, and we're going to take the union of them. All right? The union of A complement and B intersection C complement. So that's going to go right here. I'm just going to put them together. Two, 3, 6, 7, and 8. Now let's just see if the parentheses make any difference here. We already got A complement here. We already got A complement here, so I'm just going to use that again. So A complement is 3, 6, 7, and 8. Remember, that's an 8. All right, and then we're unioning that with B now. So I'm going to write that up here. So we're just going to put those two into one pot. Two, 3. So the union of these two would be 2, 3, 5, 6. 7 and 8. All right, now C complement intersecting. Let's see if I got this right. I might have a little mistake. We might have to go back because we're not, these are supposed to be the same, but so that's what this is here. So now we need the intersection of those two. Oh, wait a second. Let me remark that. Okay, that's the A union B complement. That's the right-hand side. So what we're taking now is the C complement, and then we're intersecting with this. It looks like we're missing one. I may have to go over this and bring back. I just went over this one on the fly to finish out the time. Let's hold on a second. Go back through my work here, see which side is wrong. So B is 2, 3, 5, and 6. C complement is anything not in C, so that's 1, 2, 3, and 8. 1, 2, 3, and 8. These two put together as intersection was, wait, yeah. But this side was 2 and 3 was the only common ones between these two. And then we union that with A complement. 8. So on these, maybe it's right. So it's intersection. So this one doesn't hold, is what it amounts to. Well, anyway, I'm right. This is right. When I put these together, that's what you get right here. But they're not equal. I was just double checking. So this side is equal to this, and this side is equal to that. So these are not the same. Now I'm just going to put 2. They are not equal. Because this one's got this one has 2, 3, 6, 7, and 8. This one has 2, 3, 7, and 8. It's missing the 6, so they're not the same. All right, so then what we'll do is tomorrow we should have plenty of time. So bring any questions because we're going to be on the cusp of that first test. Getting a good grade on this test is it's really I guess you would say a confidence booster. So this may well be your easiest test. I'm not going to bank on that, but like I said, it is generally that's the way it works. The easiest material. So do your best on that review. Know it forward and backwards by the time we get to that test on Thursday. Because remember, we are testing on Thursday. Everything moves twice as fast during these breaks. I mean, during the summer session. We don't really even have a break. So see here. All right, so I'm here. If you got any questions, otherwise I'll see you tomorrow. You okay, Chantel? You got any questions?
No, thank you. I'm just trying to exit myself out. Thank you.
All
But
right.
of
I'll
course,
have,
I'm still trying to figure out how to download this
yeah.
lockdown. I'm very
I think
concerned.
what it may well be is it may be one for the school. I'm going to contact somebody today. I'm going to write them an email and then that should handle it. Like I said, if not, as long as you got the one done and Alex, that
Yeah,
verification over there, that's all I'm worried about.
yeah. So,
Okay.
Professor Cruz, our test
Mhm.
they consist of like kind of like what I be doing at Alex. So no
Well, it's
problem.
like what you're doing in over here in the see, this is they're not in Alex in on the 120 side. So you click on these. So
Okay.
this is covers. So you want to make sure you're up to all the way down to here. Okay.
Okay, because I haven't done any assignments in 120
Well,
yet.
yeah,
That's
but they're
why.
up there. See, now I want to mix this. This is what.
Uh-huh. Okay. All
See,
right.
I highly recommend that you work on these within 2 days. Okay. Of
Okay.
what's covered in class, especially during the summer, because all of a sudden then, because nothing's going to prompt you and say, well, the homework is due. It's all going to come due at one time, but it'll be due after the test. It technically comes due, but then you can still work on it. It's hard
All
to
right.
explain. But
I
go
got
in
you.
here.
I must misunderstood something in the beginning.
Yeah, just
Okay.
these here.
All right.
All right.
Okay. I'll start working on it today.
Okay, bye-bye.
Thank you. Have a good day. Bye-bye.
Okay, bye-bye.